if you ever come across an equation that looks just like this, where you notice we have the variable right inside the parentheses here, we also have the variable w over here. What you're going to do is I'm going to show you pretty much how, the process you can use to solve this type of equation. So the first thing I notice is that we have a set of parentheses here. And again, the goal in an equation when you're trying to solve it is to isolate the variable to one side. So before I can even access this w, I got to make sure I use the distributive property first, which means I got to distribute the 2. So each term inside here is going to be multiplied by the value 2. So that's the first thing I recommend, is use the distributive property. So now we're going to do 24 equals, so when I multiply 2 times w, I get 2w minus, and then when I multiply 2 times 8, I get 16. And then I bring down the minus 7w. So notice that we took care of the distributive property first. And now I notice that we have w, right, appears twice on the same side. So that lets us know the next step, because again, you're trying to solve for w, which means our next step should be to combine these two. And notice that I highlighted the sign in front of the 7, because that's going to let you know what to do if you're going to add or subtract these two numbers. So it's like almost you have to ignore the negative 16 and you're just looking at 2w minus 7w. Notice they're on the same side, so we don't use properties of equality. Like a common mistake I see is you might end up doing this, opposite of this, and add it on the same side. We don't do any properties of equality unless it's on the other side of the equation. So here, they're on the same side. You just do the operation that's, that combines them. So in this case, it's 2w minus 7w. So I'll write down 24 equals, and when I do 2w minus 7w, I get negative 5w, and then minus 16, I'll bring that down. So again, don't use the properties of equality if they're on the same side. That's only if the variable you're solving for, if they're on different sides. Then you use the properties of equality to combine them. And now you can see we have a two-step equation where we're solving for w here, and the term that's on the same side, we don't want that there. So we're going to use the additive inverse to eliminate it. So the opposite of a negative 16 or subtraction is to add 16. So plus 16. And when I do the one side of the equation, when I'm solving it, I got to do the same thing to the other side to keep it balanced. And notice this is called the addition property of equality because I added the same amount to both sides. So again, notice these are like terms, and I'm adding it, I'm doing the property of equality to different sides of the equation. So I would never use the property of equality for the same side, like I was mentioning in the previous step. So now I bring down my equal sign, and when I add this up, I get 40. And on the right side, again, when you use the additive inverse, in other words, when you combine opposites, they come out to be 0. So those are gone, and we're left with negative 5w. And now we're left with one more step. So we're solving for w, so I know I got to still work with this side. And one thing I want to remind you is that if you see a number next to a variable, that implies that these two are being multiplied together. And to solve this, what's the opposite of multiplying by negative 5? Opposite of multiplication is division, so I'm going to divide by that same number, negative 5. And I'm going to balance the equation by doing the same thing to the other side. So always balance it. So whatever you do to one side, make sure you do it to the other side so that your final answer is correct. And keep in mind, when you divide a number by itself, you're always going to get back 1. As long as that number is not 0, meaning like if you had 0 divided by 0, that's undefined. So as long as this number is not 0, when you divide by itself, you're always going to get back 1. So we get 1w here. And when you divide a positive divided by a negative is a negative. 40 divided by 5 is 8. And keep in mind, we don't usually write the 1. So your final answer should be negative 8 equals w. So again, these mean the same thing. We just don't usually write the 1 down because you can see here, if you look at it, there's only one w there. So the answer for this is w equals negative 8. So now here's example 2. We're going to solve for v. And now again, notice that we have a set of parentheses here. We have the variable we're solving for inside the parentheses, and we also have the variable v over here as well. So whenever you approach a problem that looks like this, the first thing I recommend you're going to do is to use the distributive property. So here, because again, you're trying to solve for v, and you can't do anything with, you can't combine like terms unless you access this letter v inside the parentheses. So to access this letter here, this variable, we have to use the distributive property first, which means you're going to multiply each of these terms by the number here, the 2. So again, that 2 is being multiplied with both of these. So the next step, I'll rewrite it, 3v. So now plus, and then we do 2 times v is 2v, and then 2 times 6. Again, and we're doing plus. 2 times 6 is 12. So after you distribute, each of these are doubled. So 2v and 12. Then I bring down my equal sign, and then we get negative 23. And now you can see that we eliminated the parentheses by rewriting it, right? We simplified it, and now you can see we have access. That's what I was saying by having access, is that now that we don't have anything, blocking us, I guess you could say, we can actually combine these two terms because they're on the same side. So after you use the distributive property, combine like terms is the next step. And in this case, it's just 3v plus 2v, which gives me 5v. And then I'm going to bring down the remaining terms. Plus 12 equals negative 23. And now you see all that we have here is just a two-step equation. So again, we're solving for v. So when you're looking for the variable you're solving for, whatever other terms are on the same side is you want to eliminate it. So in this case, the one that I did not highlight it, I want to eliminate that term, the plus 12 here. And we're going to use what we call the additive inverse. And the additive inverse means use the opposite. So opposite of adding 12 or the opposite of a positive 12 is negative. So subtracting 12. And when you're solving equations, if you do something to one side, you got to do the same thing to the other side to balance the equation. So since I subtracted both sides by the same amount, 12, we call this the subtraction property of equality. And now when I simplify this, when you combine opposites, we're going to additive inverse. When you combine opposites, that comes out to be 0. That's gone. And we're left with just the term 5v. Bring down my equal sign, and when I combine this, I get negative 35. And now we're down to the final step. We're solving for v, but we don't want 5v. We want the value of 1v. So keep in mind, 5v means 5 times v. They mean the same thing. We just don't write the multiplication sign. And to solve this, you just ask, okay, what's the opposite of multiplying by 5? Opposite of multiplying by 5 is to divide by 5. So I divide by 5, and if I do, so whatever I do to one side when I'm solving an equation, I got to do the same thing to the other side. So I'm going to divide this side by 5 as well. And you can see here, by doing the opposite, dividing by 5 instead of multiplying by 5, you can see that 5 divided by 5 is going to give us 1v. So that's always true. As long as this number is not 0, any number divided by itself, you're always going to get back 1. And on the right side, negative divided by positive is a negative, and 35 divided by 5 is 7. And you usually don't write down the 1 for the variable if it's a 1. So we just leave it as v equals negative 7 for our final answer. But keep in mind, these are identical. It's just that we don't usually write the 1, because if you look at this here, you just ask them how many v's do you see here. There's only one v that you see right there. So that they mean the same thing. And that's the final answer. So v equals negative 7. So just to recap, though, in the first example, don't forget that if your terms might be separate like this, it doesn't mean that you're going to use a property of equality. You're not going to add 7 to the same side. You just do whatever operation is there. So almost like you basically ignore this minus 16, and you just do 2w minus 7w, which is negative 5. Because a common mistake I see is that, you might try to say, okay, let me add 7, do the opposite, and add 7 here. But that is a property of equality that you only do to balance the equation, so on the opposite side. If you add the same amount to the same side, your equation is no longer balanced. And then, same idea here. These are on the same side. So again, if they're on the same side, you just do whatever operation it says. So here it says 3v plus 2v, which gave us 5v. You would not say, okay, I'm going to combine these, so I'm going to do the opposite, minus 2v minus 2v. That's a common mistake. So again, you don't do the same thing to the same side. You only do that to the opposite side. So different sides of the equation, which is what a property of equality is. So if they're on the same side, don't do the opposites. You only combine them based on whatever the operation is. So in this case, we just had to add them, and that's how we got 5. And then the last thing I wanted to mention is that notice that, we're still using the basic properties of equality to solve it. In this case, we had to do subtraction property, then division property. In this one, we did addition property and then division property as well. So notice that you're still using those 4 basic ideas of properties of equality. The only difference is that when you get, to more complicated equations, you got to first, you might have to distribute first, then combine like terms. And then once you do those things, then you could go back to your properties of equality to solve for the variable.